Okay, then welcome to another maths lesson. Let me get myself set up, and we're a little bit not behind, but the program does lots and lots of lessons on this equivalent fractions. So it's to help you really embed your understanding. There's a few different ways of understanding it, and it's good to repeat things. However, I don't want us to do fractions for the rest of the time because fractions is really boring. So what I'll do today is I'll probably go through quite a few lessons in one go. However, don't think you have to finish all this video tomorrow. Okay, you can either whiz through it or keep it in the background and have a go at the questions, and when you get stuck, try and refer to the video. I'll try and make it clear at what lessons I'm on, so you can match that with the worksheets. But yeah, because I don't quite know if people are getting this or they want some more time. And there's quite a few other things that I want to get on with fractions that are going to make a little bit more sense as to why we're doing all this work on fractions. So I might be doing what seems like a lot, but please don't think, oh, I've got to do tons and tons and tons. Just do however much you can. And if you don't understand at any point, that's fine. Either keep watching the videos, rewatching them to try and see if it makes sense, ask somebody for help, message me for some help, have a go. And then if not, then it's fine, because we will do all this again when we're back at school properly. Right then, so we've been looking at equivalent fractions, we've been looking at fractions that are different but are the same amount, because we know that when our denominator in our fraction gets smaller, when the lower number gets smaller, our parts are getting smaller. So one of the questions could be, to start off with, is would you rather have 1/8 or would you rather have 1/12? Now hopefully all of you are saying I'd rather have 1/8, because even though that looks like a bigger number, yeah, you're not getting more of your whole, aren't you? You're splitting your whole into 12 pieces, which are, the pieces are going to get smaller and smaller and smaller the more parts you split it into. And remember, that's all a fraction is, parts of your whole. So if I've got 2 equal chocolate bars, let's say 2 pizzas, or I've got, let's say, some money, I've got £20. I'd rather have 1/8 of that £20 than 1/12, because the 1/8 is only split into 8 parts and the 12 is split into 12 parts, so it's going to get smaller and smaller. Hopefully you had a go at doing your fraction wall as well. And this is a really simple tool to just, if you're struggling with equivalent fractions, this will just make things so much easier, because you'll be able to see and work it out visually without having to worry about all the maths behind it. You could just go, right, well, it's telling me what's 3/4 equivalent to. I'll just go down. There's my quarters. There's 1/4. There's another 2. There's 2/4, 3/4. I'll go down and see that it doesn't go 5th, 6th, 7th. It does 8ths. 1, 2, 3, 4, 5, 6 eighths are the same as 3/4. So that's one. If you've got this beside you, equivalent fractions will not be a problem, because you can use this to help you. Let me just go find the doggo. You get back up. So we're looking at your fraction wall, and that should, if you've done that, if you've done your own, even better. But you'll also see that, you know, if I was comparing these strips, I'd rather have a half over than 1/12, because a 1/12 is a tiny piece. Yeah, and 1/8 is, it's not much bigger, but it's a little bit bigger. Okay, so we're just going through a bit of recap to start off with. And equivalent fractions is going to be really useful in some of the other lessons. So if you've really got the hang of this without your fraction wall, then you're well on the way, because there's going to be some pattern spotting and some division and times table knowledge definitely needed in the next couple of lessons. Can you add these two fractions together? Can you add them together? Everybody should be saying, no, you can't add them together. Why can't you add them together? Because my denominators are not the same. Super duper. Just move that across. Let's look at some of the lessons. So hopefully you've got strips or bits of paper and you're showing that I can split them into 6 halves, and I've used the fraction wall and I can really see how things are equivalent. So 1/2 is equivalent to what? Well, maybe I'll use my fraction walls. 1/2 is equivalent to 2/4 or 3/6 or 4/8. There is a pattern there. Hopefully people are starting to see that. And then again, you can pause the videos whenever you want to do the questions. These ones, I didn't really like these questions. They seem to go back a step, but it's just giving you another representation of fractions on the number line. So instead of your whole being a piece of paper or your whole being a circle, the whole is just, imagine your number line 0, 1. The one thing that I wish that they'd do with these number lines is just maybe extend it one more, because yes, you've got 0, you've got 1 hole, but you can also have 2 holes and 3 holes. Imagine we were dealing with pizza or cakes, the common things that fractions always get used. Yeah, we don't just have to have 1 hole, we can have 2 holes, and I can split that second hole into the same amount of fractions as I did the first. So again, the worksheet wasn't much better either. It's the stuff that we've already done. Just can you fill in the fractions? What fraction would that be? Or maybe you might get confused and think, well, that's 7, that's 8, 9, and you're going up in your denominators, but the parts don't change. Your denominator doesn't change. It's just the numerator shows you the amount of parts. So I think you guys will have no problem doing these, but there are the answers anyway. Remember, if I'm going too slow, you can speed up the video or skip the bits that you want to do. So I think, well, let's move on to here. So hopefully everybody should be clear that a half can be either 2/4. I can split my half again, or I can split those quarters again, and I can have the same bit shaded in every single hole, but here the part's getting smaller, so I'm going to need more in the denominator for the smaller parts to make up the same amount in a half. And maybe you've seen a pattern between the two, and especially with a half is half of your whole, and if your denominator is showing you how much your whole has been split into, surely there's a relationship between what half would be. 2, 1, 8 and 4, 4 and 2. Those numbers do ring a bell to me. Hopefully you have seen that. And you guys make sure you're pausing this and reading the detail a bit clearer. I'm just explaining it in my own words. You should be looking at this alongside me, not just listening to my voice, watching and reading as I'm talking. 1/2 can also be the same as 3/6. I can split that half into 3 and the other half into 3 and have 6. And 3/6 is the same as a half. This guy over here, this little gent, what's he saying? What do you notice? 6, 3, 8, 4, 4, 2. What do you notice about numerators and denominators in equivalent fractions? Well, you should notice, and this is a common rule that you will hear throughout your life of fractions, that if we want to keep things the same, we've got to do the same thing to the top number as we do to the bottom number. So here, to get from 1 to 2, I've times it by 2. So then I'll have to times the bottom number by 2. Or if you're like me, maybe you've seen that pattern. If this is my whole, this is the amount my whole has been split into. Half of my whole is going to be half of those parts. So if I split it into 4 equal parts, half of my 4 is 2, so we're going to have 2 quarters. If I split it into 6 equal parts, then what's half of 6? 3. Yeah, fractions are very similar to division, almost identical. That fraction line is a divide. So here, what I've done to my numerator? Well, I've times it by 3, so I've got to do the same thing to the bottom. So whatever you do with fractions, if you're comparing them or looking at 2 different fractions, there's a rule that you can say to yourself a couple of times, whisper it, shout it, say it in a silly voice. Whatever I do to the top, or whatever I do to the numerator, I do the same to the denominator. So if I've times the numerator by 4, I've got to times the denominator by 4 to keep things the same. So then 1/2 is the same as 5/5. Well, what have I done to get from 1 to 5? I've times it by 5. What's 2 times 5? Is that 10? Is he correct? I think so. Let's double check with our picture. This is the kind of methodology that you should be doing. Can I do it in a picture? Can I do it in a number line? Can I show it in my fraction wall? Here's a half. Here's my whole. It's been split into 2. Here's my whole. It's been split into 10. 5 parts of those 10 are the same as the whole. Get it? Hopefully. We can have a little practice of these. Remember, whatever you do to the numerator, you've got to do the denominator and vice versa. So here, it's asking what's equivalent, what's 1/5 equivalent to in tenths? Well, I know that I can get, how do I get from 5 to 10? What do I have to do to get from 5 to 10? I have to times it by 2. 5 times 2 is 10. So whatever I do to the top or bottom, I've got to do to the other. So if I times that by 2, I've got to times this by 2. Yeah, I'll do it here. 1/5 is the same as or equal to something tenths. So again, if you were confused, if this method is confusing you, go back to your fraction wall, go to your fifths and match it with tenths and see what you get. You'll get the right answer. You just can't always take your fraction wall with you, so try and get comfortable doing both as you move through this unit. But now we know that if we're looking at equivalent fractions and we want to look at seeing which fractions are similar, we can, if the denominator and the numerator can be times by the same number, then we will have equivalence. So I know that I can get from 5 to 10. There is 5 and 10 are multiples of each other. To get from 5 to 10, I have to times it by 2. This is why your times table knowledge is so crucial, because it's it's hard for me to go back and explain to you why 5 times 2 is 10, or to spot that relationship. That's where people get mixed up with fractions, because if that times table knowledge isn't there, then I've got to explain to you why 5 lots of 2 is 10. But if you know that 5 add another 5, or 5 times 2 is 10, then this bit is easy, because now you know that I have to just do the same to the top. So 1 times 2 is 2. 1/5 is the same as 2/10. If you wanted to use your fraction rule to double check with your methods, absolutely do that. There's a fifth. There's tenths. 1/5 is 2/10. The camera never lies. Where are we? Right, take a breather there. I'll put the worksheet on the board. If you're working from the screen, I will put it on the document as well if you want to print it out. But I don't think you need to print these out, guys, because you're just going to waste paper, and we've already had these in a workbook. So please don't. If you can work from the screen, you're not sharing, just do that, please. So here you've got 1/3 is equivalent to 1 to how many? 6. Well, what's the relationship between 3 and 6? What have I done there? If you're confused, set it out with your fraction strips. Yeah, so that 1/3 there is the same as 1/3 here. The fraction is just part of your whole, and this is a different representation of it. And then if you got comfortable with that, try and see if you can spot your patterns. What have I times that by to get from 2 parts to 4 parts? I'll put the answers on briefly, but again, pause the video and do these if you can. If you want to leave it there or go back and have another look, or look at some other questions that look at that, then be my guest. But we're going to move on. We're going to do a couple of lessons today. Right, so let's start with the in focus as always. How else can we write 2/5 as tenths? So all that question is saying is, can I write 2/5? Can 2/5 be the same as tenths? So there's my tenth. Is there a numerator is there a part of tenths that would be the same as fifths? Well, there's a few things you can do. You could start maybe splitting this up to get tenths. You split each one in half and get tenths, and do it that way. Or maybe you could use your fraction rule. Go to 2/5. Go down how many tenths. Or you could use our multiplication method. Well, is there a number I can times to get from 5 to 10? Yes, there is. 2 lots of 5 make 10. So I now know that whatever I do to the bottom or whatever I do to the top, I've got to do the same thing to the top or the bottom. So here I've times the denominator by 2, so I've got to times the numerator by 2 as well. 2 times 2 equals 4. And there you have your answer. Tick, tick, tick. If, for example, what if the question said, can we write 2/5 as 12ths? can 2/5 be equivalent to 12ths? Hopefully you've gone through your steps, but if you're at this stage here, if there is not a multiple that you can times these numbers by, 5 and 12 don't go into each other. There's no way of getting 5. I'd have to have used, I couldn't do it. So therefore, 2/5 cannot be equivalent to any 12ths. It just wouldn't line up. You know how some of the fractions don't line up. So quarters, you can't ever get fifths into quarters because they just don't. The parts will never be equivalent. They'll never be the same. That's all that means. However, we could get 2/5 as tenths because we now know that there is that I can times 5 by 2 to get 10, and then whatever I do to the bottom I do to the top, and that's an easy way of just finding out what's the equivalent. Can you add those together? A bit of a challenge question. No, you can't add those together because the denominator is not the same. If you're feeling like you want a challenge already, we'll get to this. We will get to this probably in year 4, I think. Can you make those denominators the same? Let's move on. Again, what about this one? Well, 2/5 is the same as 4/10. We've done that. What about 2/3? 2/3, the same as 9ths. 2/3 and 9ths, can they be equivalent? Can thirds and 9ths be equivalent? Can you make the parts match up? I think you can, because you should. If you know your times tables very well, you'll know that 3 and 9 are multiples of something. What times by what makes 9? 3 times 3 makes 9. 3, 6, 9. So then I just do the same. 2 top. 2 times 3 is 6. And then if you were estimating or double checking in your mind, you'd be thinking, well, what does 2/3 look like? You can have either that circle fraction, or here it's nearly your whole, isn't it? So you only need one more part to get to your whole. So if you got an answer of maybe 2/9 or 3/9, if you've just put 2/9 again, you'll know that 2/9 is a tiny portion of your whole, whereas you need to have nearly your whole again. Clear around it up. So spotting patterns, which is denominators, to find the equivalent fractions really, really easily. I'll throw the worksheet up again, pause it and have a go. There aren't many questions on these ones, which is tricky because sometimes it needs that repetition just to practice it to get it into your head. But if I'll try and find some other questions on the internet, or if you're not getting it, you're struggling, just go back a bit and watch it again and listen again, or pause it and read the lesson yourself. I won't throw the answer this time, actually. I'll let you guys find the answers for yourself. Yeah, we are going to carry on, plough through some of these, because they're all fairly similar, but they are tricky, so I don't think I'm going through them. They're easy. It's still really tricky stuff, but because they're all similar, if you're feeling confident, you can go on to the next section. If you're not feeling too confident, you can have another go or keep practicing or trying. Again, what was the last thing? You can go back through and revise it if you want to. There's some extra questions in the guide for practice that you can do actually. Forgot that. So here, everything is split into quarters. Can I get my quarters into 12s? Right, split each quarter into 3 of a bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That could be one way of doing it, or you know, is there a link between 4 and 12? Yes, there is. 4, 8, 12. Times that by 3. That has to times the top by 3. Yeah, and like I said, that link is very similar to if you know your division facts and times tables facts really well. If I've got 4 parts, but I actually want to see that in 12 parts, I know that I've got to split 4, got to get each part, it's got to be split into 3, because 4 times 3 is 12. It is all linked to your times tables and division facts. That's why we go on about it so much. If you know the link between 4 and 12, fractions shouldn't be an issue. It should not be a problem, because you'll be fine knowing that it's just part by whole. But if it takes you a while to see, if you can't see the link between 4 and 12, if you don't know that 4 lots of 3, or 3 lots of 4 lots of 3, because that's 1 lot of 3, 2 lots of 3, 3 lots of 3. 4 lots of 3 is 12, and it's going to really slow you down. And also really just bear in mind that 12, is actually a smaller part. Yes, when you talk about multiplication, you usually talk about things getting bigger, but fractions is just different because you're dealing with parts of your whole. So when you're getting the denominator bigger, when you're timesing this by 3, it's not getting 3 times bigger, it's actually getting 3 times smaller. I know, it's complicated, but stay with it and you guys will be fine. Let's move on until we get to something a little bit different. Still finding equivalent fractions. It's all the same stuff, it's just practice, repetition. So here's just one last page on equivalent fractions. Is it possible for, it's just the other way around, isn't it? Can 2/3 be equivalent to 8 somethings? If I've got 8 parts. Okay, so things that we could rule out, could it be thirds? No, well I'd have, that's a bigger fraction than what I've already got, so it can't be that, because that's, could it be 2/8? Could it be 8 quarters? No, because there would be 2 wholes. Again, if you're not sure, go back to fraction wall, make a strip of thirds, or make a strip of eighths, or there's a picture there that you can make. You could draw it, or you could make it out of paper. Make sure you try and keep your parts as equal as possible, though. here they've got their 2/3 and they split their thirds even more. We also know that I can go on my pattern knowledge. What is whatever I do to denominator, I do to numerator, but here we've got the numbers for numerator. Is there a link between 2 and 8? There is. 2 times 4 is 8. So all I need to do is do the same to the bottom and that will give me my answer. What's 3 times 4? 3, 6, 9, 12. Easy peasy. It really is that easy. Yeah. And then going back to just remember what we're doing this for. If I had that pizza, that chocolate bar that we love to talk about so much, and I split it into 2/3, I split one into 2/3, and I split another into 8/12, it wouldn't matter whether you got 8/12 or 2/3, because they'd be the same. You might think you're getting more because you've got more parts. You might think, well, no, I've actually got more because I've got 8 parts there, but I've only got 2 parts here. Yes, you would be right. You do have more parts, but because the parts are smaller, you end up eating just the same. So there's some of the challenge questions that you see sometimes in papers. Which would you rather, 2/3 or 8/12? Well, they're both the same, so it doesn't matter. Again, have a go at some of these. Look at a pattern. If you're not sure, go to your fraction wall. It's a bit trickier doing it this way because you'd have to go to half and see what 6 of something is. But we did look at this pattern as a half because a half is your whole split into 2 equal parts, and your whole is 2. So here, that is 6 parts would be half of my whole. So if I double those parts, I'm going to get the whole again, aren't I? Again, if what I'm saying isn't making sense, don't worry, I'm trying to cater for all ability levels. I'll show you the worksheet for that one. There you are. Remember, I really think that you can work from the screen. I will print these off and put them on. I'll print them off. I'll put them on a document for you if you want to have them. But it's going to save you paper and printing, and you can just easily copy them in. It's going to, if you copy it just like the question is, you don't need to write all of the sentences. But if you can practice using a ruler and keeping things nicely set out and presented, you're going to save the planet with the paper and the toner and ink and stuff like that. You're also working on your presentation. You can try and see how people set stuff out to make it logical flow. I think we'll do one more maybe. No, we won't. No, we'll leave it there. So we're pretty much done equivalent fractions now. It took us a little bit longer. So we're behind a day in the timetable, but we'll try and put the other 2 together on Friday. And then Friday working. Ugh. But then have a go back in the video, have another go, have another listen. I'll try and find some extra questions out there, although if you type equivalent fractions into Google, you'll probably find something similar and you can have a go. Yeah, so there's loads of stuff out there. It's quite Year 3 equivalent fractions into Google. Year 3 equivalent fractions. You type this into Google, I'll write it down so you can see it. Year 3 fractions, please put worksheet. You might get some other stuff. I don't know what you'll get, but if it looks like you could do it, have a go. If it doesn't look, if it looks too hard, don't worry about it. Yeah, and remember to be, make sure you're using it carefully. Good job, guys. I know a lot to do, so remember you don't have to do it all. Do as much as you can. I'll come back to it when you've got more time. So you don't have to complete all this lesson in one go. Well done, and I'll see you next time. Goodbye.